Welcome to this tutorial. Today we want to look at solution to nth order homogeneous linear differential equations with constant coefficients. Remember we started with doing first order differential equations. We want to second order differential equations. Now we want to look at nth order differential homogeneous linear differential equations. So if you have not checked on first order differential equations on how to solve such homogeneous linear equations and the second order, kindly check up the videos up there. You'll see how we tackled them. In case you have any question, leave a comment and I'll be able to respond as much quicker as possible. Now remember to subscribe to this channel and share it with your friends. Welcome to today's tutorial. So from our previous we are in this case we are just trying to generalize things because we looked at first order and second order. So we want nth. So you'll find that we said a differential equation of this kind of form, this form is the linear independent solutions. The linear independent solutions are of this form, of that form, and it has what I called in previous equation tutorial auxiliary or characteristic equations. So it will be basically a solution of those lambdas. Solution of the lambdas. These lambdas are actually roots. They will give us roots. So if we have that generally, the solution to the differential equation is done by the roots of the auxiliary, which are actually these. So they may be distinct, they may be repeated, they may be complex. So if they are complex, repeated, we use the general solutions that we are going to look at. Although I looked at in the first second tutorial on how to solve second order homogeneous equations. So in this case, look at this. This is a third derivative minus to second derivative and so on like that. So you can see that example. So how do you solve this? So in this case here, we introduce the lambda. That is auxiliary equations or the characteristic equation. So you'll find that is true. So where we have y, I introduce lambda. Okay, then derivative becomes power 3, second derivative power 2, first derivative power 1. Okay, and so on. Then I solve this one using quadratic way of doing it, solving polynomials. So if I solve this, I'll find the roots are actually these 3 roots because it's I expect 3 roots. So if you look at these roots are distinct. So they are distinct. So general solution for this will actually look like this, where lambda 1 is 1, lambda 2 is -1, lambda 3 is 2. So if it was a high VP initial value problem, then I could be able to solve for the constant C1, C2, and C3. But in this case, this was not a heavy problem. It's not a high PP problem. We cannot see that. So this becomes the solution to the equation. If you have any question on either part of this, kindly leave a comment. Let's look at example 2. Example 2 now. Example 2. We have this. The D here is an means derivative operator. It's a differential operator. D is a differential operator. So it stands for D over dx. So if I square this, I also square this, and I square this, and so on. So if it's n, this becomes n, and n. So this is a differential operator, called a differential operator. So don't worry if you see this. So this is a fourth derivative, and yeah, already I have shown it here. So it's a differential operator. So next we look at auxiliary equation. So we get the function of lambdas. So substituting, we have that, and then we solve this. When you solve this, we find that lambda is, first lambda is 2, second lambda is 2, then lambda is 3, and fourth lambda is 4, -4, the fourth root. So you can see there is repeated roots in this. So how do we do with repeated roots? Generally, for the part for repeated roots follows like that. You can refer to the previous tutorial, or now we did repeated roots. Up there, check the tutorial that we did. And again, if you have question on that, you can also ask. Then the other part is for distinct roots, and they are here. That's part. So combine together and you get the general solution for that homogeneous differential equation. Okay, so that is it. So if you have any question on either of the part in this, kindly leave a comment. I'll be able to respond to you as much quick as possible. If you have a question that you need some guidance, leave it also under the comment, and I will be able to look at it and do it for you. Subscribe and share to your friends. Okay, bye. Thank you for today. Until next time.